Hello, this is William from Visual Components. In this video, I'm going to show you how to mount and dismount tools from a robot. To get started, I have a layout open in the 3D world, which you can find a link to in the video description. The easiest way to mount a tool to a robot is to physically connect the components using the PMP command. For example, I'll select this tool component here in the 3D world. Notice the PMP command is active, and I'll now drag the tool toward the end of the robot's arm, and notice the components plug into one another, and now this tool is mounted to this robot. Now in some cases you may want to mount and dismount a tool from a robot during a simulation, and I'll show you how to do that now. For example, let's go ahead and dismount this tool that's currently connected to the robot and place it over here on the table. To do that, I'll go to the Program tab. I'll use the jog command to select the robot in the 3D world, and let's now add some sequences to the robot's program for mounting and dismounting this tool here. So in the Program Editor panel, I'll click Add Sequence, and I'll rename that sequence to be Dismount Tool 1. I'll then add another sequence and rename it to be Mount Tool 1. And since the tool is already attached to the robot, let's actually program the Dismount Tool sequence first. So I have it selected here. And now we want to move the tool over here. So I'm first going to change the orientation of the robot and its tools. So I'm going to use the Move tool in jog mode to rotate the robot around the y-axis, and I'm using these tick marks to increment the values. So now I'm at 90 degrees, and now the tool is facing downward. I'm now going to use a shortcut for the Align tool, so I'm going to hold down the Shift key and now point to the location of the tool I want to align with some point on the table. So I'm going to pick this bottom edge corner point there. So I'll click that point, and I actually forgot to hold down the Shift key, so I now am moving and aligning the robot based on that point that I'm dragging. And that point right there looks good, so I'll let go of the Shift key and the mouse button. And now it's aligned, and I'm going to press the Escape key to exit out of the Align command. And you can see output printed here showing that I started using the Align tool, and now I'm finished using it. So let's now save this location in the robot's program. So in the Dismount tool sequence, let's add a linear motion statement. And now I'm going to add a set binary output statement, because when you're mounting and dismounting tools during a simulation, those are signal actions in the robot. So now I'll go to the robot and show you. I'll go to its controller properties, and in this section here called Actions Configuration, I'll expand that. And by default, signals 33 through 48 in the robot are mapped for dismounting and mounting tools, and they use the first 16 tool frames in the robot. So for output, let's go ahead and select signal 33. And see how that's set up. So when the signal value is true, it's going to mount a tool. When it's false, it will unmount a tool. And this is very similar to grasping and releasing components. You can see when you're mounting a tool, it uses a detection volume size to find a tool component around the interface in the robot that you're using. In this case, the interface for the robot is called Tool. That's where you're mounting tools, and this is located in the mount plate of a robot usually. And notice that this action is using tool frame 1 in the robot. For a mounting tool, it'll use a gravity direction to find a component that it can attach the tool to when it releases from the robot. And the interface is the same one. It's using that tool interface in the robot. So let's see how this works. I'll go back to the Program Editor panel, select my set binary output statement, and in the Statement Properties panel, I'll set output port to 33. And since we're dismounting the tool, I'm going to not select this checkbox here for the output value, so I'm signaling a value of false. I'll then move the robot back up, add that as a linear motion statement for retract, and I'll teach that as a approach position, so I added a point-to-point motion statement. I want the robot to go to position 3 first, so I'll drag that to be at the start of the sequence. So the robot approaches the position, goes down to dismount the tool, it dismounts the tool, and goes back up. So let's see how that works. I'll reset the simulation, and notice the robot returns to its initial joint configuration. And now let's run the simulation. And I actually made a mistake. I'm sorry. I forgot to call the Dismount Tool 1 subroutine in the main routine of the robot, so apologies. I now have the main routine selected. I will now add a call sequence statement, and I'm going to call that Dismount Tool 1 subroutine, and run the simulation. The robot moves into strike, and it dismounts the tool. Let's now teach the robot to pick up the same tool or mount it. So I will reset the simulation. I'll go to the Mount Tool sequence in the Program Editor panel. And since we're using very similar statements that are in the dismount tool sequence, what I'll do is I'll go back to the dismount tool sequence, select the approach position of P3. I'll then go to the mount tool sequence here and add a point-to-point motion statement. I'll then go back to the dismount tool sequence and select my position for when I let go of the tool. I'll go back to my mount tool sequence and add that as a linear motion statement. So I'm using position 5 now as the approach. I'm sorry, position 4 as the approach, so I should move that to be at the start of the sequence. The robot will then go down to grab the tool. I need to add a set binary output statement. In this case, I'm using that same signal of 33, but this time the value has to be true, so I'm going to select the output value checkbox. I'll then move back up to my approach position and I'll add that as a linear motion statement, so it's my retract position. So I'll move position 6 to the end of the sequence. So go to P4, go down to mount the tool, and move back up with the tool. So let's actually see how that works. I won't forget to call that subroutine, so I'll select the main routine in the program editor panel. And after I dismount the tool, I'll call another sequence to pick it back up. So in the statement properties panel, I want to call the mount tool 1 subroutine. Let's run the simulation, and the robot should dismount the tool. So far, so good. It goes back down to pick up the tool, and it mounts the tool. Now, if you're going to mount a tool to a robot and use that tool to grasp and release other components during a simulation, I recommend that you first physically connect the tool to the robot, teach the required sequences, and then add the sequences for mounting and dismounting that tool. For example, I'll reset the simulation, and notice I already have a tool connected to the robot here. Now, some tool components are modeled that when you attach them to a robot, they're attached to some node in the robot. So when you interact with the robot's joints or move the robot as a component, the tool moves with the robot. So if I actually move this joint here, you can notice that the tool is moving with the robot. Now, some tools also have signals, and those signals can be modeled where they automatically connect with signals in the robot. For example, if I go to the show group and select the signals checkbox here, you can see that signals in the robot 100 in and 100 out are connected to two signals in the mounted tool called box gripper. Now, these signals most likely control the opening and closing of some joint, for example these plates here. So let's see how that works. I'll go back to the show group and clear the signals checkbox. I'll now use the jog command to interact with the tool, and it seems these plates are interactive. So when I hold the left mouse button, notice I can drag the plates away or closer together. Now, I'm getting a joint limit error in the 3D world. That's why these plates are highlighted red. So the joints are exceeding their set values. To fix that, I'll reset the simulation. I'll go to the limits group and select this checkbox here called stop at limits. Now, what this means is that a joint cannot exceed its minimum value or its maximum value. So if I now interact with the tool again, notice I can move the plates apart to their maximum value and they stop moving. When I move the plates closer together, they go to their minimum value and they stop moving. Now in this case, this robot is importing a joint from this tool, which you can see listed here in the jog panel. So here's the component, and here's the imported joint, or the external joint called joint_1. So we can see its minimum value is 0, and when I set it to its maximum value, it's at 20, and the plates are open. In some cases, you may not want the robot to import a joint from a tool component. For example, if I go back and show you the signals, you can see that there is a signal in the tool that's mapped to a signal in the robot. So this is probably modeled to where the robot sends a signal to the tool component to maybe close its plates. So in this case, you probably don't need joint 1 to be imported. But this is also listed as a component property. So if I go back to the Home tab and select the robot as a component, you can see in the component properties panel, this robot has 6 joints, so J1 through J6, and here is that important joint, joint_1. What this means is that any motion statement you teach this robot will also have a property in it for this external joint value. So just keep that in mind when you're teaching robot positions. So let's actually teach the robot to pick up that cube using this mounted tool. So in the show group, I'll turn off the signals. I'll go back to the program tab, and in the program editor panel, I'll add a new sequence called pick cube. And we want to use the robot to pick this top face of the cube here. So in the jog panel, I'll use base 1. And for the tool center point of the robot, let's actually use the imported tool frame from the mounted tool called gripper tool 1. And since I'm going to be doing a grasp and release action, I want to use a native tool frame in the robot that's already mapped to perform a grasp and release action with a signal. So in this case, I'll use tool frame 1, and I'm just going to translate it or change its position to be the same position as the imported tool frame. We can't see that right now, so I'll go to the 3D World toolbar, click the Frame Types arrow, and I'll select this checkbox here called Robot Tools. So this shows tool frames in the 3D world. There's the native tool frames in the robot, and here's that imported tool frame. So let's actually go to the jog panel and select Tool 1 in the Tool Property. I'll click the gear icon, and you can see Tool 1 is selected in the Tool Properties panel. And now let's snap Tool 1 to Gripper Tool 1. So in the Tools group, I'll click the Snap command, and in the Tool Snap Task pane, I'll set the snap type to frame. So this allows me to select frames in the 3D world. And let's go ahead and point at the imported tool frame. The preview looks good, and I now move Tool 1 to that same location as the imported tool frame. And the benefit of this is if I was to dismount this tool, I still have a point of reference of where that imported tool frame is in the robot. So now let's go ahead and teach the positions. So in the Program Editor panel, make sure you have Pick Cube selected, that sequence. I'll now go back to the jog panel, and if we want to set our tool to be the imported tool frame of Gripper Tool 1, I'll now use the jog command to select the robot, and then I'll use the snap tool, and let's go ahead and snap to that top face of the cube there. So the preview is showing the mounted tool to the robot right now. The preview looks good, so I'll click, and now the robot is at that location. Now one thing to notice is that the plates of this tool are open right now. They're at their maximum joint value. Now what you could do is you could change the joint value of the tool, and if you want to save the state of the tool's joints, you can do that by either starting the simulation, or you can click the setting arrow here in the simulation controls, and then click the Save State command. Now this will save the state for all components in the 3D world. Right now I have the robot in some type of joint configuration, so I do not want that to be the initial setting for the robot. So I'm actually going to reset the simulation first, and then I'll just make sure that the joint value has a maximum value of 20, and then I will use the setting arrow and save its state. Let's now teach the position again over here. So in the Tools group, I'll click Snap, and let's make sure our base and tool frame are set up first. So yeah, when you reset the simulation, the configuration goes back to null. So we're using base 1 and gripper tool 1, and then use the snap command to snap the robot right there. Let's now teach us as the pick positions. So in the pick cube sequence, I'll add a linear motion statement, and we're now going to add a set binary output statement, and we want to signal the tool component to close its plates so it can grasp the component. So in the statement properties panel, I'll set output port to 100, because remember, the signal in the tool component is connected to signal 100 in the robot. So if the output value is true, that most likely means the plate should close. Let's now add a set binary output statement for grasping the component in the robot. So by default, signals 1 through 16 are defined to grasp and release actions using the first 16 tool frames in the robot. So we're using tool frame 1, so I'm going to use output signal of 1. Set the output value to true by selecting this checkbox so it signals a grasp action. And then what do we want to do? Well, we want to move the component back up. So let's go ahead and raise the robot up, add that as our retract position and our approach position. So in this case P9, we need to move that to the start of our sequence. So the robot will go to P9, it'll go down to P7 to pick up the component. It'll then send out a signal for the tool to close its plates. It will signal the grasp action, and then it will lift the component back up. Let's see how this works. So I'm going to reset the simulation, and I will remember to call this subroutine in the main routine. So let's actually cancel out of these routines right here, so I actually will delete those. And now I will add a call sequence statement for pick cube, run the simulation, and let's see how this works. Alright, the plates closed, but you can see the robot was picking up the cube while the plates were still closing, so we should probably add a delay statement there. So in the pick cube sequence, when we signal for the plates to close, I'll add a delay statement. And in the statement properties panel, let's use a delay of 1 second. We're not in any hurry, and see how that works now. So I'll run the simulation. Robot moves down to strike. The plates close, and the robot moves back up. But what's happening here? It seems that the plates of the tool are opening up. So that's when the robot is going to that retract position. position 8. So I'll select the statement here in the Program Editor panel. And if we go over here to the Statement Properties panel, you can see that at that external joint, that imported joint from the tool component, has a set value in this motion statement. So right now it's set to its max value of 20, so that's why these plates are open. Now to fix this, you could use the jog or interact command and then just set the joint value for the tool however you want to. And then in the Program Editor panel, you can click this Touch Up command. Or you can just edit the statement directly in the Statement Properties panel. So I can just set E1 to be 0, press the Enter key, and if I reset the simulation and run it again, the robot will go down, the plates will close, picks up the cube, and when it moves back up, notice that the plates are still closed. So as I mentioned before, be very careful when you're importing a joint from a tool component in the robot. Let's now run through all the sequences in the robot's program. So I'm going to reset the simulation and just zoom out a bit. And what do we want to happen first? So in the Program Editor panel, I'll select the main routine. And before we call pick cube, let's actually dismount the tool. So I'll add a call sequence statement. And in the Statement Properties panel, I'll set routine to be Dismount Tool 1. I'll then add another call sequence statement, and I will set it to be Mount Tool 1. So after the robot dismounts its tool, mounts the tool, it will then pick up the cube. So let's reset and run the simulation again. The robot is going to get rid of that tool. Get rid of that, you don't need that. Oh wait, you do need it. So the robot will go back to pick it up. The robot picks up the tool, and now it goes down to strike, and it picks up the cube. Great. Now, when the robot was mounting the tool, you might have noticed the plates moved a bit, so that's probably due to that external joint property in the statements I have. So I'll reset the simulation. I'll go back to my Dismount Tool 1 sequence, and I'm now actually going to select all the positions in this sequence. So I'll hold down the Control key and add P1 to the selection and P2. You can see that their E1, their external joint value here, is 0, so that's fine. I'll now go to the Mount Tool sequence in the robot. I'll select P4, P5, and P6. And let's see. Yes, I'm sorry, I understand. When the robot, initially the plates are open in the gripper. So in this case, it doesn't matter if they're open or closed. So what I'll do to make it simple and pretty is I'll select these statements here in the Mount Tool 1 sequence and set the external joint to be 20. And I'll actually show you how to do it the other way. So I'll use the jog command, make the joints at their max value, use the touch up command in the Program Editor panel. It seems it didn't work, so I actually will go back and set this directly for all three of those positions. And then I'll go to Dismount Tool and do the same for the other positions. So let's actually try this again. So I'll just have one statement selected this time, touch it up, and yep, you can see there that the E1 value is now 20. So I'll do the select P1 and P2, and this time I'll just type in the value. So max value of 20. So if I run it again, we should see that beautifulness. So yep, the plates stay open, and then the robot goes and picks up the tool again. And the plates are still open at their max value. So now when the robot goes to strike, everything works out. Marvelous. All right. Now if you want to model a tool component like the one I'm using right now in the 3D world, you can go to the Modeling tab. And we do have a wizard that makes modeling a tool component very easy. So if you go to the Extra group, click Wizards, you can click this command here called End Effector Tool. And this will set up everything you need for modeling a very complex tool component very quickly. Now one more thing I want to cover before I end the video is what if you want to mount and dismount several tools during a simulation. For example, I may want to mount this tool to the robot. Well, I'll show you how to do that now. So I'll reset the simulation, and I'll go to the Program tab. And now instead of calling the Pick Cube sequence, I'm going to delete that. But I will add another sequence for mounting and dismounting another tool. So for sequence 1, I'll rename that to be Dismount Tool 2. And add a sequence for mounting tool 2, so mount tool. And now what tool do we want to mount? Well, let's mount this tool here. So to teach that position, notice I'm working in the mount tool sequence. I first need to not have this tool attached to the robot. So in my main program, I'm going to do some magic here. I'm going to dismount the tool, delete that call to the mount tool 1. So I will add a call sequence statement. And then in the Statement Properties panel, I will call the mount tool 2 subroutine. And then in the routine I'm teaching now, I'll add a halt statement. So this allows me to stop the simulation. So I run the simulation, the robot should get rid of that tool, and then the simulation should stop. So yep, so now I can teach the robot positions for picking up or mounting this tool here. So in the mount tool sequence 2, let's go ahead and snap the robot to that face center there. And now instead of using tool frame 1, I'll just use tool frame 2. So I will add a linear motion statement. I'll then add a set binary output statement. And in the statement properties panel, I'll set the output, instead of 33, I'll use 34. And this uses tool frame 2 in the robot. And I want the output value to be true to mount the tool. And let's move back up. Add that linear motion statement for the retract position and the approach position. P12 is going to be our approach, so I'll drag that to the start of the sequence. So the robot will then go down to mount the tool. It signals the mount tool action and goes back up. And let's actually get rid of that halt statement. We don't need it. So reset the simulation, run it again. The robot gets rid of one tool, and then it goes to pick up another tool, like so. And now to dismount this tool, I'll go to my Dismount Tool 2 sequence. And notice we have nothing there right now, so I'll go back to my Mount Tool 2 sequence. Sorry for jumping around. I know that I want P12 to be the approach position for the dismount tool, so I'll add a point-to-point motion statement now. I'll go back to Mount Tool 2, get that linear motion statement down to where you pick up or mount the tool, and then I'll go to the Dismount Tool 2 sequence, add a linear motion statement, so this will be the position where the tool is dismounted. So let's actually move that after our approach position. I'll then use a set binary output statement, and we're using tool frame 2, so I'm using output port of 34, and the output value is false. And then we're moving back up to position 13 as the retract, so I'll add a linear motion statement and have that set to be at the end of my Dismount Tool 2 sequence. So now let's call both of these for Mount Tool 2 and Dismount Tool. So after Mount Tool 2 sequence, we will call the Dismount Tool 2 subroutine, reset. Let's run the simulation again. So the robot gets rid of that tool. It picks up another tool. And then maybe the robot changes its mind, doesn't need that tool anymore. It goes back down and dismounts that tool. Alright, this concludes the video. What I recommend is that you use this layout to practice mounting and dismounting tools from the robot. And if you have any more questions, please feel free to visit our forum at forum.visualcomponents.com, and I hope you have a wonderful day.